First time on these podcasts anyway, we've got not only n's in there, but we've also got x's, a variable x. What we're going to be doing with these series eventually is making functions. And we want to know for what values of x is the function going to converge. The overall idea is you have some function and you've got a graph of the function that's like this, and you're not sure what function it is. You've just got a graph from some data or something like that. So what you can then do is create a power series, and what will happen is you've got, let's say, some x value here. What will happen is you can create a power series that will converge, so your series will go like this, and it will copy this function. If you're lucky, it will copy it forever, but it may be that it copies it for this area in here. So you say, oh, as long as x is in this region right here, then the function that I created with the power series, it's exactly the same as the function that was created by this crazy data in here. Then we can use the power series in place of the crazy data, at least within this region right here. So that's what we're doing here, is we're trying to find out what x values work. Well, this one right here is a good candidate for the ratio test, because when you have an exponential and you divide them using the ratio test, then you get something like 2 to the n plus 1 gets divided by 2 to the n. You're left with just a 2. So I'm going to do ratio test. The same reasoning goes for the x, because you'll have x to the n plus 1 and x to the n, which will cancel and leave behind just a single x. So take the limit as n goes to infinity. First of all, substitute n plus 1. And then you divide by the nth term, which is going to be, well, if you're dividing by a fraction, invert and multiply. So the 2 to the n goes on top, n squared goes on top, x to the n on the bottom. And then usually I leave off absolute value, because this is positive and positive and positive, but now we've got this friend x, and x may be positive or negative. So now I do need those absolute values. All right, now do the algebra. So we would have 2n will cancel this n, leaving just a 2. X to the n will cancel this n, leaving just an x in the numerator. So for the numerator, we have n squared and a single x. For the denominator, we have this single 2, and then this, which I'll just go ahead and multiply out, is going to be n squared plus 2n plus 1. But then, times 2. So it's 2n squared plus 4n plus 1, or plus 2. And then we would have, well, since there's n squared over n squared, those are going to essentially cancel and leave the 2 on the bottom. If you want, you could go ahead and use L'Hopital rule twice. So you'd get 2n over 4n plus 4. Then you would get a 2 over 4. And so you end up with that it's absolute value, an x on top, and a 2 on the bottom. So then we're doing the ratio test, which says in order for it to converge, then you need it to be less than 1. So you say this has to be less than 1, which means that in absolute value, x needs to be, if you multiply by 2, needs to be less than 2. Or in other words, x ranges between -2 and +2. So my picture doesn't correspond to positive and negative values, but that's the idea, that you've got a range of values that it will converge for. Now the other fun thing is, does it equal 2? Does it equal negative 2? Well, if you substitute a 2 in, you'll have 2 to the n. If you've got, so for x equals 2, we get this as the series. 2 for x and then, lo and behold, these cancel. You're left with just 1 over n squared. And if it's the series 1 over n squared, that's a p-series. With this being bigger than 1, it converges. That means that x equals 2 should be considered. Or in other words, this should actually be a square bracket. And this should actually include the 2. And then what about negative 2? Well, negative values only make the series smaller, so I'm pretty sure this is going to converge also. So when you put a negative 2, it's going to look like negative 2 to the n over 2 to the n squared. What you could do is factor out the negative to the n and 2 to the n. And then, just like the other one, the 2 to the n's will cancel. Now it's an alternating piece series. Well, if this one with all positive values converges, then this one that alternates positive, negative, it's also going to converge. In fact, it's even going to converge to a smaller value and converge faster. So that means that should also have x equals negative 2 as a possibility. So here finally is the interval of convergence. I actually did more than what was asked. The question asked for the radius, which actually has you stop right here. The radius is, you go out by a radius of 2 in either direction. R equals 2. But I wanted to do this extra part for extra fun.